Hypothalamus Artificial Intelligence, HI. Digital transformation powered by real-time autonomous and intelligent algorithms. Presents the short conference, Artificial Hippocampus. It corresponds to one of several short conferences, in which the advances of HI research are presented, on the topic of artificial brains and decision-making artificial intelligence. The list of short introductory lectures to decision-making artificial intelligence are presented in the picture. Artificial Hippocampus, a mathematical models expert systems. The hippocampus. Storage structures and processes from the decision-making that must be faced permanently. The artificial hippocampus is based on the mathematical synthesis of the information generated by algorithms and problem-solving processes, to use it in new runs of these algorithms to speed up the problem solution in real time. Artificial hippocampus store, like in the humans, the experience, and the knowledge acquired over time. Mathematical modeling expert systems. A knowledge-based system, KBS, must store two types of knowledge. Mathematical components, equations, problems, models, previously used and working properly. This information is generated by the modeler who builds the mathematical models and their entire operating environment, and results of previous runs to speed up the solution of new problems. This information is generated by the math models when they are used, and correspond to the trajectories of the variables involved in these models. The use of this information is totally dynamic, since it depends on the value of the input parameters in each new run. Artificial hippocampus. Storing mathematical components. OpTex, HI's artificial intelligence to develop artificial brains, manages the artificial hippocampus. It is oriented to make high-complexity large-scale mathematical models without programming. The models are built in a modular way, as if they were a Lego set, which are formed by a compatible system of equations, the Leo parts, for all models. When considering that an artificial brain will gather, in an integrated way, the mathematical models required by an organization, we must be aware that a traditional approach, based on programmers, is a very difficult path, if not impossible. As everything has evolved, HI has developed OpTex, the artificial intelligence to produce artificial intelligence algorithms. The interested party is invited to watch the video. Making high-complexity large-scale mathematical models without programming. Artificial hippocampus. Storing the history of runs. While mathematical models on digital computers, and the data storage disks, date back many years, more than 60 years, and despite the Industrial Revolution 4.0, how to run a model, it does not seem to have evolved. The normal process is: the model is thinking monolithically. A high-performance solver is selected to solve the problem, and the results are post-processed, and the results of the models are stored, with administrative purposes. Usually, in the next run, the model starts from scratch, ignoring the past, that is, it has no memory. In some cases, it is heated from a starting point provided by the last run, presumably the last optimal solution, or a point that ensures feasibility. However, an artificial hippocampus, designed for the artificial brain, can take advantage of a lot of information produced within a run, and during the history of all runs. Two examples will be briefly presented. Handling of Bender's theory, and generation of convex hull. Following the principles developed by Bender's, it is possible to build an artificial hippocampus that remain active, and useful, beyond the duration of a run of a computer model. To do this, the cuts generated in each run must be stored in such a way as that they may be used later. This implies a coordination work, since it cannot be guaranteed that the information as it is produced can be reprocessed later. An artificial hippocampus stores cuts from one run to be used in the next, which will produce new cuts. HI is researching in the creation of methodologies to generate new rules that fit the dynamic variation of the parameters that affect the models. The process is similar for Lagrangian relaxation. Another alternative to generate knowledge, that is stored in the artificial hippocampus, is the generation of convex hulls, associated with optimal solutions of the mathematical problems. The multidimensional grid that represent the convex hull can be incorporated into the integrated problems to accelerate the solution process. Depending on the specific problem, the convex hulls may be permanent, or they must be recalculated dynamically when the parameters of the mathematical models change. Convex hulls allow flexible approaches, as in the case of an energy transmission system, in which they can be associated to two different ways to solve the problem: flow AC and DC flow. The production of convex hull of optimal points is a standalone process, therefore they can be generated outside the optimization process. The new way of mathematics is directly related to the parallel thinking, and today it can be said that, like paper-based math, sequential mathematics for single-processor computers will be in the short term a dead language. As in the human brain, in the future only parallel mathematical thinking will be practical. The new analytics is autonomous, parallel, and distributed. Thank you for your attention.